All right, so part two, we're going to continue on. And so we're going to look at a couple more of these functions. And so here we are. F of x equals negative 3 times x squared minus 2x plus 7. And so for the first one, we're going to evaluate the function at the value 5 right here. So we're going to plug 5 in everywhere we see right there. So let's see, f of 5, I'm going to sneak it right here. So negative 3 times 5 to the power of 2 minus 2 times 5 and then plus 7. So 5 squared, we got to do that first. That will give us 25. Then minus 2 times 5 plus 7. And then let's see, next we will take care of our multiplication here. So we're going to get negative 75 minus 10. And then don't forget our plus 7. And then let's see, our next step is to go ahead, let's see, negative 75, take away 10, that's negative 85. And we'll add 7 to that, and that should give us negative 78 right there. All right, our next one, we're going to plug in negative 3. So let's see, we have negative 3 parentheses negative 3 squared minus 2 times negative 3, and then we have that plus 7 right there. So first, we'll go ahead and square the negative 3. So negative 3 times negative 3, that'll actually become a positive 9. Minus 2 times negative 3 plus 7. Then we're going to multiply here and here. Negative 3 times a 9 is going to give us negative 27. And then you have this minus 2 times a negative 3. Basically, we have the double negative rule going here, so that's going to turn into a plus 6. And then we have our plus 7 right there. And then let's see, so then negative 27 plus a positive 6 is negative 21. And then plus a 7. That should get us to negative 14. All right, this next one's going to be a little tricky here. We're going to be plugging in the x plus 1 right there. And so I'm going to write it right here. So x plus 1. So we're going to have negative 3 times the x plus 1 squared minus 2 times x plus 1 and then plus 7. So we did have something like this in the previous video. And so what we're going to have to do here is we're going to have to square this. And when we square it, you're actually going to break it apart and FOIL it. And let's see, I don't have a lot of room here, but let's see. So negative 3 times x plus 1 times x plus 1. And then I'm going to go ahead and distribute this now. So let's see, minus 2x minus 2 plus 7. Okay, so this is where it's going to be a little tricky. You're going to have to FOIL this, and then after you FOIL it, you actually do need to distribute that negative 3 to whatever we get from after we FOIL. So we're going to have the negative 3, and then I'm going to keep this in brackets. So when I FOIL this, I'm going to get an x squared, then I get 1x, and then I get another 1x. So I'm just going to go ahead and combine that together now as 2x's. And then 1 times 1 is 1. And then over here, I still have my minus 2x. And if I want to, I can go ahead and combine this minus 2 and plus 7. So minus 2 plus 7, that should give me a positive 5 right there. So I went ahead and kind of cleaned that up. And I'm doing that just because I really don't have a lot of room to finish this. So we're going to distribute here and then combine any other like terms that I have. So let's see, we're going to have negative 3x squared. This will become a minus 6x and then a minus 3. So I multiply negative 3 by all three of those. And then we still have the minus 2x and the plus 5. And I'm going to just try to put it over here on the right side. So let's see. I don't have any other x squareds except the negative 3x squared. Then I have a minus 6x and a minus 2x, so we can consolidate that to a minus 8x. And then the minus 3 and a positive 5, if I add those together, that's a positive 2. And there we go. That's what we want for part C. Okay, the last part, part D, I'm going to scroll back up so I can see the original function. And so we're going to plug that negative x in there. So let's see, we're going to have negative 3 times negative x squared minus 2 times negative x plus 7. All right, so then we saw this earlier. Basically, that negative in front of the x is kind of like a negative 1 times x. So like kind of negative 1 times x. So when I square this, this actually will turn into negative 3 times just a positive x squared. And then right here, a negative times a negative, that'll become a plus 2x. And then we have our plus 7 right there. And then the last thing we want to do here, I mean, technically you could leave it like this, but I'm going to go ahead and drop the parentheses here and just write this as negative 3x squared plus 2x plus 7. And there we go. That's it. All right, let's take a look at example 4 here. So we have a square root. So I'm going to plug in whatever we're evaluating the function right here. Just in this first example, I'm going to plug a 2 in there. So let's see, we're going to have the square root of 6 minus 2. And then we have a minus 5, which is on the outside. It's not part of the radical. So then this will become the square root of 4 minus 5. Square root of 4 is 2. 2 minus 5 is negative 3. Okay, the next one, we have a negative 1. So we're going to get the square root of 6 minus negative 1. And then that minus 5 on the outside right there. Those double negatives will turn into addition. So square root of 6 plus 1, take away 5. So we're going to end up with the square root of 8 minus 5. And if you can simplify the radical, we do want to do that. And in this case, we can. We're going to break that into the square root of 4 times the square root of 2. And I can take the square root of 4 because it's a perfect square. So we're going to end up with 2 square roots of 2 minus 5. And there we go. Okay, and then our last one, we're going to substitute in x minus 6. So we're going to get the square root of 6 minus, now be careful here, x minus 6, and I want to put that in parentheses, and then minus 5. Now I put that in parentheses because I do actually need to distribute that minus right here. So it's going to go here and here. So I'm going to end up with the square root of 6 minus x plus 6, then take away 5. Okay, and then it doesn't really matter what order I put this, but I'll go ahead and add my 6's together right here. So this is going to be the square root of 12 and then minus x and then minus 5 on the outside right there. And that looks good to me. So you might be thinking, well, wait a second, 12, we can break that up kind of like we did the 8, right? Well, you have that minus x right there, so we can't break that up. If you have addition or subtraction, unless it's factorable or something like that, you're just going to have to leave it like that. All right, so moving on, I got a couple more. I believe we're going to be looking at some fractions. Here we are. And so h of 2, so I'm going to go ahead and plug 2 in for each where I see x. So let's see, we're going to get 4 times 2 squared minus 5 all over 2 squared. And so then we're going to get, let's see, 4 times 4 minus 5 all over 4. Now don't try to reduce the 4's right there. We can't do that because the minus 5 is also getting divided by 4. So what you have to do is complete any simplifying on top and bottom and then see if you can do any reductions. So let's see, we're going to get 16 minus 5 over 4, which then is 11 over 4, and we can't reduce that, so we'll just leave it just like that. Okay, on example B here, we'll go ahead and plug in negative 2 this time. So 4 times negative 2 minus 5 all over negative 2 squared. And let me square that one right there. All right, Well, let's see what's going to happen here. So we're going to get 4 times, well, negative 2 squared becomes a positive 4 minus 5 all over negative 2 squared. That's also positive 4. And it looks like we're actually going to get the same result. We're going to get the same result, 11 over 4. Interesting. Okay. And actually, on the next slide, we're going to kind of talk about this. And so I'll just go ahead and give you a little sneak preview. This is going to be known as an even function. And what that means is that if whatever you plug in for h of x is equal to if you plug in h of negative x. So whether I plug in 2 or negative 2 or 5 or negative 5 or so on, I'm going to get the same result. Now, what I did in part A and B don't actually prove it. I have to go ahead and figure out is h of negative x equal to h of positive x. And so that's what part C is actually going to do for us. I'm actually going to go ahead and plug in negative x, and if my answer is actually the original function, then I have proven that this is an even function. And like I said, we'll talk a little bit more about this on the next slide. So let's see, 4 times negative x squared minus 5 all over negative x squared. All right. Well, once again, you kind of have those little negative ones in front. So whenever you square it, it's going to turn positive. So it just becomes positive x squared. And then we have our minus 5. And then all over. And then once again, when I square this, negative times a negative, it becomes positive x squared. And what you'll notice is it's actually what the original function was up here. Okay, so we'll talk more about that on the next slide. This next one, it's not an even function, so don't really have to worry about that here. But I do have a couple values I want us to evaluate the function at. So let's start with 2. So let's see, 2 minus 5 over 2 plus 2. Well, that will give us negative 3 over 4. And that's it. All right, let's try negative 7 now. So let's see, negative 7 minus 5 over negative 7 plus 2. And so we're going to get negative 12 over negative 5. Good answer, but better answer is positive 12 over 5. So those double negatives are going to cancel each other out. And so we want to write that as positive 12 over 5. All right, our next one, 0. We're going to plug in 0. So let's see, we're going to have 0 minus 5 over 0 plus 2. 0 take away 5 is negative 5. 0 plus 2 is 2. And there is our answer, negative 5 over 2. Okay, the last one, we're going to plug in negative 2 here. So let's see, we're going to have negative 2 take away 5 over negative 2 plus positive 2. Interesting. Okay, well, we're going to end up with negative 7 over 0. That's interesting. Okay. Well, if you're unsure, it's actually going to be undefined. Okay, undefined. So if it's under the line, it's undefined. Now, if you had 0 over negative 7, that does actually equal 0. Okay, but in this case, it's undefined. And I won't go too deep into the weeds on this, but basically, this is how it works. So if you had something like 10 divided by 2, you know the answer is 5, right? Or if you had 15 divided by 5, you know the answer is 3. And the pattern that's getting established here is that if you take your divisor and multiply it with your answer, it should equal the numerator, right? So you can see, 2 times 5 is 10. 5 times 3 is 15. And if you look up here at this example, negative 7 times 0, well, that's 0. That makes sense. That makes sense, right? Well, what can you multiply 0 by and get negative 7? Well, we don't know. So undefined. So we don't typically, in math and science, a lot of times we don't want to say for certain what things are sometimes. And so in this case, we say undefined in case somebody can come up with something. All right. So our last slide is actually going to be looking at even and odd functions. And so we'll first look at some graphs and then look at some equations. So right here it says if the graph of a function f is symmetric with respect to the y-axis, so this is our y-axis right here. So if the graph is symmetrical with the y-axis, we say that it is an even function. That is, for each x in the domain, f of negative x, it's the same, it's equal. And so that's kind of what I was talking about on the other page. And so, for example, a would be an even function. This is an even function because if you look right here, f of 4, f of 4 gives me a 7, right? The the function value that you get in return is going to be the y value, which, so I plug in 4 for x and I get 7 back. Well, if you look over here, if I plug in negative 4, I also get the same result. So f of negative 4, I also get 7 back. And that's true for all the points. So for 1 and negative 1, 2 and negative 2, and so on. But if you can establish this, and you've actually proven it for the whole function. And we'll do that in a minute below. Okay, if the graph, so we've talked about even function. There's actually another type called odd. So this is for even. Okay, so even's kind of easy to remember. It's even. They're the same, whether it's f of x or f of negative x. The next one we're going to look at, it's called an odd function. So if the graph of a function f is symmetric with respect to the origin, what they basically mean is 180 degree rotation, we say that it is an odd function. And so really odd is going to kind of be associated with the opposite. You're going to get the opposite result. And so that's basically what this is saying right here. So if I plug in the negative x, right, f of negative x, I get the opposite. I get the opposite of what f of positive x was. And so looking at an example, this would be c. C would be an odd function. And so let me show you a point right here. So if you look at this point right here, so f of 3, when x is 3 for the function, I get back a 4, right? And then if you look down here at negative 3, f of negative 3, oops, see, f of, there we go, f of negative 3, I'm getting the opposite result. I'm getting a negative 4 as my result. So you can see the results are coming back opposite. And so the way you kind of define that algebraically is what we have written right up here. And then in most cases, most functions are going to fall into the neither category. So this one actually is neither. You might be like, well, wait a second, it looks like it's a 180 degree rotation. Well, that part is true, but not through the origin. It has to be an 180 degree rotation through the origin. So sure, this rotates up 180 degrees if I were to swing it around, but that's not from the origin. It has to be from the origin, like this one on example C. So like I said, this won't come up super often, but we will kind of see it here and there. So don't stress too much about this. But what I would suggest is go ahead and maybe pause the video and try examples D, E, and F. You're going to have one of each. You're going to have one even, one odd, and one neither. Okay, so looking at D, let's see. So you might think it's even, but it's not. This one's actually going to be our neither one. This is going to be neither. Now, if this U shape, this parabola right here, was actually here at the y-axis, if it was getting cut in half at the y-axis, then it would be. But this one is neither. Because, for example, f of 2 is not the same or the opposite of f of negative 2. Negative 2 is going to be way up here or something like that. So those 2 points are not even, and they're not the opposite. So they're not going to be even or odd. If you look at E, this one's going to be our even one, okay? Because you can see that 1, negative 1, I get the same thing. 2, negative 2, the y values are the same, and so on. You can pick any 2 points for x, pick a 3, negative 3, 4, negative 4, and so on, and you're going to get the same result, even results. Now F looks a little funny, but this one's actually going to be our odd one, okay? And so you get opposite results. So F of 1, I'm getting the opposite at F of negative 1, right? My Y value, instead of being close to 1, it's close to negative 1. F of 2, I'm up here. F of negative 2, I'm down here. Once again, I'm getting about the opposite result. So that you're getting opposite results. So F of x, um, you're, or well, F of negative x is equal to the opposite of what f of x is. And so that's how you write that algebraically. So whenever I plug in f of negative whatever, it's equivalent to the opposite of what f of the positive version of whatever I was evaluating right here. And so that leads us to our last part where we're going to determine whether they're even, odd, or neither. And we have to do it algebraically. We're going to have to use those formulas that are up here. We're going to have to use these to determine it. So what we do is we're going to take the function and we're going to substitute f of negative x in. And if we get the exact same function, well, that means it's even. Okay, and so that's what we saw over here. When I plugged in h of negative x, I actually got the exact same function. And so that showed me that they were even functions. Now, if I plug in f of negative x and everything comes back the exact opposite of what the original function was, if all the signs have been flipped from positive to negative and vice versa, then I know I'm dealing with an odd function. So let's go try this down here. And like I said, most of the time, actually, they're going to fall into the neither category, but we should get one even and one odd here just for practice so we can see that. So on this first one right here, I'm going to evaluate, or I'm going to substitute in f of negative x. So I'm going to get negative x to the power of 4 minus negative x to the power of 2, and then plus 2. Okay, well, once again, you kind of like have an understood 1 in front right here on those x's, those negative x's. And so just real quick, a little note here, negative 1 raised to any even power is always going to come back as a positive 1, okay? And negative 1 raised to any odd power is actually always going to come back as a negative 1, okay? So right here, this negative 1 to a power of 4 is actually going to come back as positive 1, and then I'm just left with x to the power of 4. Then minus, that's part of what was originally part of the function. And then when I square the negative 1, that becomes positive, and then I have my x squared. So once again, don't get confused. That minus here is coming from right there. And then I'm left with plus 2. Well, if you look at this, this is actually the exact same as what I have right here. They're the same. So that's going to fall into the even category. Oops. Set a little bit even. There we go. So this is going to be an even function. Okay. Let's look at b. So once again, f of negative x. So let's see, I'm going to have negative x to the power of 3 plus a negative x. Well, over here we saw that if I have negative 1 raised to an odd power, it's going to stay negative. So this is going to be negative x cubed. And then adding a negative is the same thing as just saying minus x. And so that's what I get here. And then if you look here, it's basically the exact opposite. All my signs were changed. So this one's going to fall into the odd category. This is the odd category. So what this is saying is if I plug in, let's say, for example, f of 2, let's see, I'd get 2 to the power of 3 plus 2. Let's see, that's 8 plus 2, that's 10. Well, if I plug in f of negative 2, I'm going to get negative 10. If I were to plug in f of negative 2, I will get the opposite. I will get negative 10. And if you don't believe me, you can go ahead and try that on your own. All right, so that's our odd one. Our last one, you could probably figure out which one this is going to fall into, but let's go ahead and plug in f of negative x and see what happens. So let's see, we're going to get 4 times negative x squared plus a negative x minus 3. All right, so when I square that negative x, it's actually going to become positive. Okay, and then let's see, that plus a negative x, I can just write that as minus x. And then I have the minus 3 right there. So this is what I get. And let's look. It's so close. It's almost the same, but it's not. If you look, I have a plus x and I have a minus x here. So it's either all or nothing. It's either even, odd, or neither in this category. So it does not fall into the even category. It would have to be the exact same. In the odd category, they have to all have a sign change. And so here I only had one sign change. So that's what I ended up with. All right. If you need anything, let me know.